welcome back to another video of H&H Express model nscale trains. In the last two videos I showed you how I changed my power to the track. So instead of using transformers, I'm using motor drivers to control the power on the track. Well, in this video I'm going to show you a little bit of the code which I used in the Arduino to make that happen. So let's go to the computer and see how it works.
So here is the wiring schematic again for one motor driver to control two tracks. As mentioned, I'm using the I2C bus to communicate to the PCF8574 I/O module and the PCF9685 servo board and the 16x2 LCD display. So let's scan the I2C bus and look up the addresses for those components. You can do that by using the example code within the Arduino. Make sure that the correct libraries are loaded for that. So you can find the I2C scanner under File, Examples, scroll down until you get to Wire, and then the I2C scanner. Load it into the Arduino program. I have already loaded it here. So let's upload it to the Arduino Mega. I'm gonna open up the console and I'm connected to COM port 4, and I will set the baud rate correctly because for this I2C scanner it is 9600, and you see all the addresses appearing. So we see addresses 0x20 up to 25. 26 is skipped, then we have 27, we have 0x40 and 41. So for the PCF8574, the address 0x20 to 0x25 are being used. The 16x2 LCD display also uses the PCF8574 and is by default address 0x27. The PCA9685, the address is 40 and 41. And that is in my sketch. As mentioned earlier, for the PCF8574, you can set the address by using a jumper, and it starts by default with address 0x20. The 16x2 LCD display which I'm using, the default address is set to 0x27, which means all these jumpers are placed to the left. So for the PCA9685, you can use these solder pads here at the top. With these solder pads you can set 64 different addresses, and by default it starts with address 0x40. The solder pads A4 and A5 are being used to set the addresses higher than 0x4F. If you put only A4 and the rest is open, you have set the address 0x50. Use the solder pads A4 and A5, then the highest address is 0x70. I would recommend to check the manufacturer's site on how to set the addresses correctly. So in my sketch for the Arduino, I will use the following names for the components. For the 16x2 LCD display, I will just use LCD. For the PCF8574, I will use power_MT_PCF8574_00 up to _05. This is for the addresses 0x20 till 0x25. For the PCA9685, I'm gonna use motor_driver_00 and motor_driver_01, because I'm only using two of those. So here is the sketch in the background. I have the output here, and then we have two live feeds. The top one is showing the train, which is an ICE, and when the red LEDs are on, that means that that is the back of the train, and when the LEDs are white, then that means that that is the front of the train. So when it's red, it's moving away from us, and when it's white, it moves towards us, which is actually the reverse on that track. So at the bottom you see a green light, which means the green light, when that is lit, then the track is positioned forward. If the red LED is lit, then the track is positioned reverse. And if there are no LEDs lit, then that means that there is no power on the track. Currently all the LEDs on that controller power board will be moved to a frame where we can see the total layout as I shown in the beginning. So let's go over to that script. Let's stop the videos and move the COM out of the way, and then I will show you and explain what is happening. So first of all, we have the libraries which I use. Those are the wire library, that is to control the I2C bus. Then I have the liquid crystal underscore PCF 8574 library, that is to control the LCD. Then I use the Adafruit PWM servo driver library, that is for the PCA 9685 to control the pulse width modulation. And then I use the PCF 8574 library to control the I/O. During our scan, we saw that the I2C addresses were 0x20, 21, 22, 23, 24 and 25 for the I/O. That is what I configure here. So I have power underscore MT underscore PCF 8574 underscore 00, which corresponds to address 20, and underscore 05 corresponds to address 25. Then we have the LCD, and I mentioned I just use LCD as the name. I configure that at address 27 because that's the default address of the PCF 8574, which is behind that LCD display. Then the motor drivers, they are on address 40 and 41. So this is the whole initialization of the addresses. Next, I use to read current values to read from the current sensors. So for each track I defined a current sensor reading, and I will use that within the program. I created a function called LCD underscore display. It just displays the lines on the LCD display. It sets the cursor at the position where I want to have it, and then I just print that line on the LCD. In the setup section, I set the baud rate correctly. I just print out what type of node it is on the serial port. I initialize the LCD display, so I do an LCD begin. The way that this LCD works is 16 characters and 2 lines. I set the backlight of the LCD on. I set the cursor to home and I do a clear on the screen, which means everything what was on it will be cleared. And then I use the function which I just described to put text on it. Next, in the setup function, I will initialize the PCA 9685. So I set the frequency correct, and with this one I use the frequency 1600, but in the newer versions I discovered that 250 would be the best one to do. Otherwise you will hear a high-pitched sound when, for example, a motor receives power, and you don't want to do that. I'm gonna set all the outputs towards the L298 to off, and you do that with giving it the port ID, then start, on and then off. And with this, if you do this, so for example port 104096, that means that the port is fully off. If you do port 14096,0, then that means that port is fully on. With this script for testing, I only use the on and the off. If you gradually increase the speed, then you need to set this value to lower than 4096, and you can go from 0 to 4095, and you can use percentages of it. So halfway through would be 2048, a quarter would be 1024. So that is what you can use to set the speed correctly. So I do that the same for the other PCA 9685, because I have two of them. And then I'm gonna set all the I/O pins. So all the I/O pins on each module, which are in total 6, are set as output, and I'm gonna set the value to high. You need to do that, otherwise power will be applied on the 298 motor driver and trains will run at the highest speed there is, and you don't want to do that. So then I created for each track a separate section, and we are concentrating on track 3A. That is the track where the train is standing on. What I do on the I/O controller is I set port number 4 and 5 for this track, and I set port number 4 to low and port number 5 to high. That means it will forward. So let me bring the output of the serial port. So we see here, for example, a forward, and now it says reverse. So these sections here are performing those steps. So if I want to move forward on the track, pin 4 needs to be low and pin 5 needs to be high in my case. If you want to go reverse, then pin 4 needs to be high and pin 5 needs to be low. And if you want to stop power on the track, you need to set both ports to the same position. That's either low or high. To make it uniform, I use high as default. And then the value is stopped. So here on this output you can see that there are also current values detected. Currently these are in a test phase. I will need to correct them and tweak them whenever I can. So a formula will go over that, because you need to be specified in how to detect that there is a train on that track. So let me bring the train back to it. So here we have the train back, and we see that when it says stop, the lights on the train are off. When it says forward, the lights on the train are red, which means I look at the back of the train. And when they are reverse, then they are white, which means that that will be the front of the train. And then it moves towards you. So I'm gonna put some arrows with it so you can see the direction that it is. So again, now the train moves away from us, and now the train moves towards us. And now the power has stopped. So let me grab the other. So let me bring the other camera back as well. And move this one up. So here you can see it in real action again. Forward, reverse, and stop, which means no power. And the corresponding lights. So forward, you have the green LED lit. Reverse, you have the red LED lit. and then stop, no power. So that is it for this video. If you want to see more of these videos, please consider to subscribe to my channel. If you liked it, please give it a thumbs up, and I will see you in a next video. Thank you and goodbye.